Welcome back, ladies and gentlemen. Today we're talking about finding ratios of perimeters. So let's get right to it. So we're talking about finding the ratio of the perimeters of similar triangles. And we're going to be able to use some ideas that we've used before to be able to find out the ratio of the perimeter. In other words, what's the ratio would you have to multiply to be able to take one figure and turn it into the other, so that the lengths of the sides, because that's what the perimeter is the measure of the outside of a figure, would remain the same when we're only given one length of each figure. Now, a few things I've already added. This shaded one, that's going to be our red, and the non-shaded one is going to be our blue. Here's our key to remember which one's which, because again, I'm not able to color or print anything in color. So we just got to remember that. So we got to find the ratio. This is our keyword, find the fraction of the perimeters of the similar rectangles. Well, perimeters usually means add up all the sides, but we can't. We could only technically add up two sides. So we don't know what the full perimeter is. What it's actually asking is, using one length, how do we compare the two? So we could find out the ratio if we found a side here to figure out the side on the other, or if we found the length of the side here to go back and forth. That's what it's asking. So it's asking to find the percent of a number, essentially. Just find the percent, not what the actual number of either one will be. So again, that's our fraction. So that means we need a fraction bar. So we're going to take the perimeter of red and the perimeter of blue. Well, again, we don't know the actual perimeters, but what we do know is one side of each that are similar sides. So this is a short side and this is a short side. They are similar. So I can take that and say 4 to 6, because if we remember before in our proportions, this is what we would have done. We would have compared similar sides. When I do that, I can simplify that to be 2/3, because that would have been 2 times 2. And that would have been 3 times 2, and those 2's cancel, which leaves us 2/3. And that means the ratio of the perimeter is 2/3, or 2/3 is the amount we would have to multiply. If we found out this length, we'd multiply this length by 2/3. Or sorry, if we found this length, we'd multiply by 2/3 to get this one, because that's the ratio that we would be comparing it to. So again, the ratio of the perimeters of the similar triangles is 2/3, because we compared the 4 to the 6. And the reason we compared the 4 to the 6 is we compared similar sides of similar figures. And we used that ratio to help us determine the ratio of the perimeters of similar rectangles. Now pause the video and copy what is on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write what you picked up into your notes. Use arrows, circles, shapes, pictures, whatever else you need to, but add it to your notes to make them yours. Lastly, always remember, when you're learning, it's about understanding the process, never just about the answer. We'll see you tomorrow.